So this question we need to integrate x over x squared minus 2x plus 3. So we can think about using partial fraction and then realize that actually the denominator cannot factorize. So cannot use partial fraction. So what we can do is we observe that A, is actually this can be actually we do completing the square and we can actually get a nice number for. So what will happen is here, right? Another way is we can observe that if I look at this, if this is my, we can think about, f prime x over fx dx. Wherever we have something a fraction, we can also think about the, those you got 1 over, like fx square plus a square kind of thing, right? So there's a lot of integration formulas that deal with rational functions like this, right? So this could be 1, this could also be 1. Right, there's also possible square root 1 minus x squared, all this. Okay, then after that, how to go on doing this? So actually it's quite hard. So what we do is we realize that, if you look at this as a fx, right, the f prime will be 2x minus 2, right now. And then I observe this. This is x. I need a 2x, probably. So is it possible that I create a 2x minus 2? That could be one way, right? So if I purposely put a half and I put a 2x here, right? That will actually get me somewhere, right? Dx, right? But then we're still short of minus 2. So how about if I put a minus 2 here and then I put a plus? So I can put a minus 2 here. I put a plus 2 outside. Can, right? So this is the same. 无中生有, basically I just x squared minus 2x plus 3. Of course, there's a half here, so I also need a half here, right? Notice what I'm doing. I've actually converted x. I've converted x into, like half of 2x minus 2 and then like plus half of 2. That's what we are doing here because we recognize that this, okay, this is f prime over f. And then from here, this is just half of ln x squared minus 2x plus 3. Okay, so you remember if you integrate f prime over f, that's going to give you ln of fx, right, plus c. And then this portion, looking at how troublesome we can think about another way, we can think about maybe, since we cannot factorize, we cannot use partial fraction, right? Partial fraction is not a viable option. Let's think about completing a square. If you complete a square, you're going to get x minus 1 square plus square root 2. And what comes to your mind? Alright, so if it's not partial fraction, if it's not f prime over f, likely the third choice could be what? Tangent inverse, sine inverse, or cosine inverse. So this is the sum of two squares, and likely you are going to get the outcome will just be 1 plus 2, and it will divide by square root 2 again. This will just be tangent inverse x minus 1 over square root 2. Basically, we use tangent inverse. Alright, when you do the algebraic fraction, you got a lot of ways. So number one, when you integrate maybe like some fraction fx over gx. So there are a lot of scenarios. Number one, it could be one of those f prime over fx. It could be those that you can write it in the form of fx squared plus a squared, that kind, which is tangent inverse. Number three, if you can actually do partial fraction until you have 1 over x plus a, 1 over x plus b, that kind. Right, so you do this, that's possible. Right, so this is the possibilities here. And this is just, your answer will just be half ln mod x squared minus 2x plus 3, 1 over plus 1 over square root 2, x minus 1 square root 2 plus c over square root 2 plus c.